Okay, so what happens if you combine a vision language model with an image segmentation model? Well, you can build some really complex application by tracking, counting objects, segmentation, and more. In this video, I'm going to show you how exactly to build a pipeline like this. Now, last week, Google released the Gemma 4 family, which is their first Apache 2.0 multimodal reasoning models that you can run locally. And these models are extremely efficient for their sizes. Now, there was another model release which didn't get much traction, and this is Falcon Perception. It's an image segmentation model, very similar to Segment Anything model from Meta. However, this is much, much smaller. It's only about 0.3 billion or 300 million parameters. So you can actually use this for local inference. If you take an image like this and ask the Gemma 4 what type of fruit items are present, it will be able to tell you. However, if you ask it to reason over it, it gets into trouble. In this case, I asked Gemma 4 whether there are more oranges than apples in this image. Now, by simply visual analysis, it's not able to count items correctly. It says there are 5 apples and 5 oranges, and as a result, they are the same number, which is not the case. Now, if you combine this with a segmentation model and wrap it around an agentic loop, then you can use the agent to first segment oranges, then apples, count them, and then this model can reason around the items that it has found. Now, this goes beyond simple fruit counting example. As you can see, you can really use this in practical applications. But the beauty is that everything is running entirely locally. And that's exactly what I want to show you in this video. Now, the good thing about Gemma models is that it comes in different sizes. So based on your needs and the hardware resources that are available, you can pick the model that you want. For this application, we're going to be using the Gemma 4 E4B instruction following version. This is a relatively small model that you can run on local devices. I am going to be running this on DGX Spark. There is also an MLX or Apple Silicon version available on my GitHub repo. Link to that is going to be in the video description. Now, for grounding, we're going to be using the Falcon Perception model, which is an image segmentation and detection model. This is coming out of Technology Innovation Institute in United Arab Emirates. They had some really amazing open weight models in the Falcon series, and I'm really glad that they are actually pursuing that work by including these multimodal models now. It's just a 300 billion parameter model, but it punches above its weight. I'm building quite a few projects on top of it, so I'm going to probably share those in my upcoming videos, including object tracking in real time. So if you're interested in things like that, make sure to subscribe to the channel. Okay, so before showing you the demo, let me walk you through why vision language models like Gemma 4 are not enough alone. The first thing is that are really bad at counting things if you don't put them in an agentic loop. Also, if you want to find the location of specific objects, they cannot do that. And usually if there are occlusion and things like that, you will not be able to separate objects. Scene understanding is pretty good and they are extremely fast. Now, on the other hand, if you combine it with an image segmentation model, you can actually do object counting. You can isolate and segment objects and create bounding boxes around those, and essentially use this as a basis for stronger grounding for segmentation. Now, this does come with a latency increase, which can hinder some applications. However, this 300 million parameter model is small enough that you can really run it at a very improved speeds compared to some of the older models like SAM. Now, this is not simple sequential processing pipeline. I created a whole agentic loop around this system, which combines both Gemma 4's vision capabilities with Falcon Perception segmentation capability to ensure that we use these two capabilities together to build a very robust system. Now, here's how it works. So in the current implementation, the agent is driven by Gemma 4. It has access to 4 different tools that it can use along with the segmentation model. So when the user query comes in and it needs to have an image as a part of the user query, we first use Gemma 4 for planning and routing. So it is going to determine whether it needs to use a segmentation model to detect objects or not. Let's say if it decides to use the segmentation model, this is going to simply call the detect each, and from the query, it will generate a list of items that it wants to segment. The segmentation model essentially returns a segmented image with annotation or a sequence of different images. Then Gemma 4 can do visual reasoning. Now, if the agent needs to re-evaluate or change its plan, it has that capability as well. And then we use Gemma 4 for visual analysis of the scene. This is basically the whole agentic loop. Now, the image segmentation Falcon Perception model uses something called chain of perception decoding. And in this case, it can process an input image along with a user query. So it has the ability to do both text and image processing simultaneously. And then it goes through a number of different steps to generate full resolution binary masks for segmented objects. It can also do a detection of objects, so you don't have to specifically tell it which objects to identify. You can just tell it what type of objects are present, and then it uses its chain of perception decoding to identify and detect objects in the images. It's a very strong model that you can use as a basis for further fine-tuning. Okay, so here's how the whole system looks like. There are 2 different paths in the application that I'm about to show you. It's open source. You'll be able to use the code in your own projects. Okay, so here's a closer look at the agentic loop. The main component is the planning router. If it thinks that it can easily answer questions based on the user query and the provided image, then it will simply use a sequential system where you use the segmentation model to detect objects, the vision language model to generate answers. But if there are more open-ended questions, in that case, it's going to get into this loop where it's going to do multiple different steps of using both the vision language model, the segmentation model for detection, and try to get to the answer that you're looking for. At the moment, for safety, we have set those limits to 8 steps only, but you will be able to play around with it. Also, keep in mind, the app I'm about to show you is quick experimentation. So right now I created very limited number of tools, but you can expand these based on your own needs. Okay, so this is what I'm calling Gemma Vision Agent. Code is going to be available on GitHub repo. There are 2 different versions. One is for Apple Silicon and the other one is for DGX Spark or NVIDIA GPUs. I'm going to show you the one that is running on DGX Spark. Okay, so all the instructions on how to set this up are going to be in the GitHub repo. Now, when you start the app, this is running on DGX Spark at the moment. You have 2 different options. You have the agentic pipeline, which basically uses that whole agentic system that I showed you. And then you can also do a direct comparison with Gemma 4 only and the Falcon plus Gemma 4. This is basically your whole agentic pipeline. Now, keep in mind, I am using the relatively small Gemma model, but for more practical applications, you probably want to use the bigger models. So let me show you a quick example. This comes with a few images. So for example, I can say how many dogs and what breeds are there, right? It detects there are 2 dogs, and also right now it's analyzing those with the Gemma model. And the final answer is basically there are 2 different dogs, and here are the potential breeds for those, right? So you can see we first used the segmentation model. It detected bounding boxes or segmented those dogs, and then it passes on to the vision language model to generate final outputs. Now, another very busy image. In this case, I'm asking, are there more cars than people? If you use the agentic loop, but it first identifies cars, and it says there are 14 different instances of the car. It's really hard to see from this image, but I think it's just mainly focusing on the cars that are really close to the camera. There are some in the background. Then it looks at the people that are present. Seems like it's able to identify some occluded people as well. There are definitely a few misses here and there, right? But based on that two-step process, it does a direct comparison, and we get the final answer that there are 12 people, there are 14 cars, so there are probably more cars than people. Now, this image is a very hard one to process. Now, to show you a quick comparison between these two pipelines, I have uploaded this image, and I can ask something like, are there more oranges than apples in this image? By the way, this is also real-time speech-to-text transcription that is also using the parakeet model from NVIDIA. If you're interested in this, the link is going to be in the video description. Now, if you simply rely on the counting capabilities of the model, you can easily say that it gets confused. So it starts counting oranges. At the end, it thinks there are 5 apples, 5 oranges, which is not the case. There are 5 oranges, but there are 8 different apples. And you can see that Gemma 4 gets confused. But on the other hand, if you run it through this multi-step agentic pipeline, which combines both the segmentation and the vision language model, you get pretty accurate results. So first, it has segmented and isolated all the oranges. Next, it has segmented and isolated all the apples in the image. And then the model can easily reason through whether you have more apples or oranges. Okay, so this was a quick example of how to combine both these different models with different capabilities to create a pretty complex system. Now, I'm looking at how to include video processing capabilities. There are some other models that can be helpful in real-time tracking of the objects. One idea that I was exploring is to convert things into frames. That seems to work with combining these two different models, but I think we can do better. So if you're interested in video tutorials like this, make sure to subscribe to the channel. Link to all the code is going to be available in the video description. I'll highly appreciate if you can give a star to the GitHub repo. Anyways, I hope you found this video useful. Thanks for watching, and as always, see you in the next one.